whenever I say 8 is divided by 3, so what is my remainder? And whenever 8 is divided by 3, my remainder is going to be 2. So if I take another example, if I say 6 is divided by 4, again the remainder is 2. If I say 9 is divided by 2, the remainder would be 1. So now these are known as remainder. So this also works for any polynomial, and this we say it's something like a remainder theorem. And whenever you have any polynomial, it's divided by some factor, let's say x minus r, then the remainder would be p of r. So p of r is my remainder. For an example, if I want to talk about an example, let's talk about this one. So here the polynomial is x to the power of 9 plus 9, and it is divided by x plus 1. So which means if you look at the previous thing, so whenever any polynomial is divided by x minus r, then p of r is the remainder. That's what is the remainder theorem state talks about. So this is my remainder. So by comparing these two, so in place of minus r, I have positive 1. So that is the reason the value of r is negative 1. So that is the reason what I can say is p of minus 1 is my remainder. So in this case, p of x is given. So what will be p of minus 1? So p of minus 1 would be equals to. So in place of x, I have to replace with minus 1. So that is going to be minus 1 whole power 9 plus 9. So minus 1 to the power of any odd number will result in minus 1 itself plus 9. So which is nothing but 8. So 8 is my remainder. So whenever I divide this polynomial with x plus 1, so that's how I do it. So now if I talk about, let's say I have 8 as my number. And if 8 is divided by 2, so I'll be getting my remainder as 0. Let's say I have 9 as my number. If 9 is getting divided by 3, my remainder is 0. See, I'm not talking about a quotient. Instead, I'm talking about a remainder. So whenever I get something like my remainder is 0, so in that case, I can always say this 2 is a factor. This 3 is a factor of 8. So whenever my remainder is 0, I can say this 2 is a factor or 3 is a factor. Or in other way, also you can say whenever 2 is a factor of certain number, you will always get your remainder as 0. So that is the reason. So this also works for any polynomial, and we say something like a factor theorem. So if you have any polynomial p of x, and if x minus r is a factor, then as we saw it in the remainder theorem, p of r will be equals to your remainder. Since x minus r is a factor, so that is the reason your p of r will be equals to 0. So because my remainder will be 0, so whenever we talk about a factor. And we also know that, so whenever we talk about factor, so factors using the factor, let's say if x plus 1 is a factor of a polynomial, so I can simply say this has to be equals to 0, so x should be equals to minus 1. This one is the roots of the equation. This one is the root of your polynomial. And the root of your polynomial, whenever you draw it on your xy plane, that is same as x-intercept of the polynomial. So this is what is factor theorem is. So now, if I talk about an example of how do I apply my factor theorem, as we know, so whenever a polynomial has a factor of x minus r, then your p of r, which is remainder, will be equals to 0, because whenever it's a factor, there is no remainder. So in this case, so if I compare this, in place of minus r, I have minus 1. So that is the reason I can say r is equals to positive 1. So which means my p of 1 should be equals to 0. So now p of x is given. P of 1 is nothing but in place of x, I have to replace with 1. So it would be 1 power 7 minus k into 1 plus 5 is equals to 0. So this can also be 1 power 7 is 1 itself. So 1 plus 5, which is 6 minus k s equals to 0. So that is the reason you can say the value of k is 6. So that's how the factor theorem works.